Welcome. Thank you for joining our Information Technology Best Practice Series webinar. I'm Becky Melody, your hostess for today's presentation. Sabu Vis, our IT Infrastructure Practice Lead, will be presenting. The discussion today will cover introductions, webinar logistics, direction for post-webinar collaboration, and our discussion topic, qualifying a VMware infrastructure in life sciences. We're proud to have Sabu leading our team. He has 15 years experience in technology and regulated life science domains. Sabu leads the USDM IT infrastructure practice, and he's a subject matter expert for VMware and SharePoint. USDM is focused exclusively on the life science domain. We're the market leader in providing IT, quality, and regulatory compliance professional service solutions. We're headquartered in Ventura, California, and we're a compliance partner for many best-of-breed vendors, including Agilent Technologies, Sparta Systems, OpenText, Oracle, and SAP. U.S. data management is all about performance compliance. We've delivered more than 1,000 successful projects with over 130 life science clients, and we're the preferred compliance partner for small, mid-tier, and large life science companies. We specialize in assisting clients with regulatory risk, reducing that risk while maximizing their investment in quality systems and ECM, as well as laboratory instruments and systems, and of course, IT infrastructure. The content of today's presentation will be covered in approximately 30 minutes, and then we'll invite you to post questions for our team via the iLink message board on the lower left of your screen, or you can join our discussion on LinkedIn and post questions or comments there. The overall goal of today's webinar is to facilitate discussion, share ideas, provide the platform, and then explore solutions together. We appreciate you taking the time to join us today, and now I'll turn the presentation over to Sabu.
Hi, everybody. Welcome. So I'm here to talk about virtual infrastructure and the qualification approach you need to think about when you're qualifying the virtual infrastructure. Of course, network infrastructure qualification and qualification of infrastructure in general is very important. I know most of you are grappling with that right now, and we've had guidance before in the past that we have to do the we have to qualify the infrastructure and not just stop at the application layer. And Annex 11 more recently has, it pretty much calls it out and says you must qualify your infrastructure, you must frequently test your backups and your disaster recoveries and things like that. So infrastructure definitely is something that's important that we need to address. I'm going to focus this conversation on the virtualization aspect of it, of the infrastructure. And I'm probably going to be skewing quite heavily on the VMware side. Of course, there are many virtualization technologies. I'm skewing VMware because I'm seeing that more often. And I'm seeing that more prevalent in the industry. So I'm going to skew it towards VMware. Of course, the concepts are translatable or applicable across the board with any other virtualization infrastructure. So the agenda is to kind of walk through and discuss virtualization in the life sciences, talk about the IT benefits, but also talk about the compliance benefits and what the virtual infrastructure qualification really means. As we all know, life science companies are usually a few years behind other industries, especially with respect to technology, mainly because of change control issues, documentation issues, fear of potential compliance holes. Classic example is right now, with cloud computing, we're really far behind on the cloud side. We're very reticent to adopt the cloud because we're worried about the compliance gaps and the compliance issues we might face. We're only now really trying to understand, we really understand how to qualify our infrastructure and move stuff from physical to virtual, etc. This is something that's really definitely important. There are, of course, barriers as well to going virtual. There are some software companies even today that do not support on a virtual infrastructure. They'll say, hey, we don't recommend going virtual. There are many reasons for this. Some of them are, there are some vendors who have their own Oracle, who have their own virtualization platforms that they're trying to upsell or cross-sell, and they don't necessarily support virtualization technology. Sometimes it's they haven't thoroughly tested it out in their own infrastructure, so that also provides a level of risk for a life science company to kind of adopt virtualization. But I found by and large that the advantages of going virtual far outweigh the potential hazards or potential risks. So, the fear of virtualization, and I kind of touched upon this, why should we go through the compliance hassle of virtualizing? I have my validated application. It works just fine. I manage my physical infrastructure. The servers, etc., are, roped into my, validation documentation. Why do I really have to go through the hassle of virtualizing? What does it really, what do I gain out of it? And what does it really mean to have my infrastructure qualified? I mean, what are the benefits of that, etc. So we'll talk about that a little bit today. Obviously, there are significant technology benefits or benefits to the IT organizations from virtualization perspective. Otherwise, companies like VMware would not be in business. There is a significant advantage in the fact that you can now completely forget about the underlying physical hardware. You're not tethered to a particular platform. When I talk about a platform, I'm talking about a physical platform or a type of server or hardware drivers, and etc. Because virtualization kind of abstracts the hardware out for you. So you can kind of plug and play different types of hardware, and as long as it supports your hypervisor, you're fine. And secondly, physical machines are very difficult to copy or move. With virtualization, it's very easy to kind of move your server around between hardware, between data centers even, all in a few clicks. Also, the physical infrastructure has a shorter life cycle. Stuff craps out, hardware fails, and it takes a long time for you to rebuild and reacquire a new piece of hardware and reinstall and revalidate, etc. It's a very, very tedious affair. But if you qualify your virtual infrastructure, even if your host machine craps out, and you can prove that your virtual machine can run on any host, you can just vMotion it out to another host, or using something like dynamic resource management, it automatically moves to the next available host, and it saves you a whole lot of time. So there's significant management and resource challenges with the physical infrastructure. There's server sprawl. It's much more economical to manage a set of virtual machines. Of course, it's a double-edged sword as well. You could have virtual machine sprawl, where virtual machines are spun up right and left, and there's no management oversight, or there's no control about the number of virtual machines that are spun up, and you just have all of this compute resources being wasted on a slew of virtual machines, and that's something that you need to control. So virtual machine sprawl can also happen, but it's significantly easier to manage than physical machine sprawl, and it's also less expensive because most computers are underutilized anyway. So virtualization allows you to maximize the bang for the buck that you get out of every hardware resource that you have in your data center. So here's a cool little slide from VMware as well. It kind of talks about how you could free up resources because You're managing less physical infrastructure, you're managing less upgrades, you're managing less issues related to downtime, et cetera, of your physical hardware, that you can focus more of your resources on the actual business of IT, which is app innovation, application innovation, and where you can actually service the business and really, really provide quality IT service to your business. And of course, there are significant, I'm just trying to draw something here. There are significant reduction in data center operating expenses because you're really maximizing your resource usage, which basically means you can reduce the number of physical servers you have, and in this lovely green minded economy, it's great to save some power as well. There are significant IT benefits, and I talked about most of these. We're not bound, we're not tethered to a physical infrastructure, and there are phenomenal savings as demonstrated by some data provided by VMware, and this is freely available on the internet. So let's move on to the, actually even before we discuss the compliance benefits, I also want to caution you that moving to a virtual infrastructure also comes with its challenges. One of them being, VM virtual machine sprawl. The other being you really have to qualify this virtual infrastructure for you to operate in a life science environment. But we'll talk about that as we go on. There are significant compliance benefits, and this is the big secret or the big surprise. Let's just talk about testing. We go through a variety of testing cycles as we go through validation. When we spin up a new application, or we make a revision or an upgrade to an existing application that's been validated, we bring in consultants, we get them to write test protocols, we do some dry runs, we do some testing, then we actually get those protocols approved, and then we actually do some validation testing using IQ, OQ, PQ protocols or whatever on a validation environment or a qualification environment or a test environment, and then we roll it into production and we do some IQs, et cetera, et cetera. So this is a typical validation testing life cycle, and it's significantly enhanced by going virtual. Consider this example. We had a customer where they were upgrading one of their maintenance management systems. This system manages your calibration records, maintenance records, et cetera. It's very high GMP function, very critical system. And they were upgrading the software, and it was a significant version upgrade. And we have a virtual infrastructure in our own facility, so they just turned over, took a snapshot of all of the virtual machines that they have and the database, and just shipped it over to us. And we installed it on our site, on our data center, and we played with it. We could do destructive testing. There was no tension. There was no stress about, we're going to break the system, because we could just go back to the original snapshots and bring the system back up again, even if we did truly screw it up. So we could essentially develop the documentation, do as many dry runs as we want, completely offsite, completely away from the customer site, freeing up their IT resources, us not having to nag them about information all the time. And we had the system readily available, and we could do whatever we want with it, and we could develop our test protocols and our test scripts. That's one significant advantage. Also, another thing with change control, every time you go through change control, it's probably a very good idea to have a rollback plan. And most change control documents or most change requests will have a contingency plan or a rollback plan in case the change doesn't really work out. Guess what? Virtualization really helps you in that regard. If you take a snapshot of the data before the change, and if you take a snapshot of all of the application tier, web tier machines using virtualization technologies, and if your upgrade doesn't work out or there's some problem or some issue, you can always roll back. And you can also maintain these snapshots for a particular data retention period. so that even though you made the upgrade and you're not, you have a 3-month, 6-month probationary period where the bugs need to be ironed out and you still don't like the new upgrade, you can always revert back to your old system. Of course, making sure that the data that has changed since the time of the change, you can kind of roll that back as well, or you can use that data. So those are significant compliance benefits, and really enhances the compliance score of your system. Furthermore, there's enhanced business continuity and disaster recovery capabilities with virtualization. You can use VMware's Site Recovery Manager and pretty much bring up your entire data center on the other side in a matter of hours. If you have if you've replicated your underlying data and your data stores at the storage area network level to another redundant data site, another redundant data center, you could, using tools like Site Recovery Manager and other tools, you can really essentially bring up these virtual machine files, and you can bring up these virtual machines on the other side pretty much in a few clicks. A few clicks of a button, you're up and running. From a backup perspective too, I talked a little bit about that. Virtual machines themselves can be backed up, and you can take a snapshot of that and manage it and maintain it for a particular period of time. There's also a significant advantage with respect to support for outdated hardware, and I'm going to talk to you about a particular example where I had a customer whose policy was to retain data for a retention period a couple of years more than the expiration date of their longest standing drug or something like that. So one day the FDA inspector walks in, and there was some, he was specifically looking for some data from an old VAX-based HPLC system. I don't know if you guys remember VAX. An old VAX-based HPLC, liquid chromatograph system. So that old computer system would store data in tapes. I don't know if you remember these old tapes. These tapes, the IT people went back to try and get these tapes to load it up again to look at this old data. They had fossilized the entire system because there was no way to kind of migrate that data. They had fossilized the system, and they found out that while trying to access that information from these tapes, they were actually destroying the tapes because the tape readers become so old, etc. So here's this weird catch-22 situation where to the auditors or the FDA guys, they go and tell them, hey, we can look back at this data, but guess what? If we look back at this data, we're probably chewing up the tape and we're going to destroy it forever. So it's a weird catch-22 situation. But with virtualization, you're really not tethered to a hardware type. As the hardware improves or you move to different hardware platforms, the virtualization infrastructure will move along with you, and you can manage your data, etc., in a much easier way. So the big secret, we can really increase your compliance score with virtualization, and there are certain cost benefits associated with that as well. So this graph, this data is actually sourced by us, and we have we collect a lot of data about how long projects last on various systems, etc. So we found that systems that are validated, systems that are that reside on a virtual infrastructure are much easier to validate, because a lot of the underlying testing that we do on like backups, disaster recovery, etc., can kind of be rolled into the underlying network infrastructure qualification, or in this case, a virtual infrastructure qualification. So we can kind of reduce the amount of time that we spend in testing these the first time we validate, and on an ongoing basis, it really helps us with managing time, especially the client's time and the customer's time, because we can spin up these machines, we can spin up test environments almost at the click of a couple of buttons. We can do destructive testing. We're not afraid of playing with the system and afraid that it will break, etc. So there are a lot of significant advantages there, and we found a lot of significant cost benefits as well. Furthermore, the fact that you could back up and perform some disaster recovery a lot easier as well is greatly helpful. Let's talk about virtual infrastructure qualification in general. And I've kind of layered this in a sequence of layers. I start from the top where you have the validated application. And again, this is very, very typical. You have an application. We develop requirements for that application. We want that application to automate some business process. So we develop user requirements and functional requirements, and we design the system, and we write design specs, and then we test all of those specifications out in IQ, OQ, PQs, etc. This is very typical validation lifecycle deliverables. There's a validated application that sits on top. And in this case, we just focus the testing on the application. We really divorce any infrastructure layer related testing out of this. Things like backup and recovery and other infrastructure items, say single sign-on security, etc., can be handled at the infrastructure level. So you can kind of really focus on the application itself. Then another way of looking at it is, okay, so I have the application on top. It sits on a bunch of virtual machines. So what do my systems really need, or what do my applications or GXP applications really need from my VMs? Perhaps I need a Windows 2008 64-bit machine. Maybe it's a clustered database server. I need 3 or 4 machines with a clustered Oracle database or a SQL database, etc. So these are requirements of virtual machines that my system requires, and I can essentially build a toolkit or a set of templates, set of virtual machines with specific configuration specs of those virtual machines. And as long as I'm spinning up new virtual machines using one of these qualified templates, I really don't have to invest in any more documentation than that. I just manage it through configuration management. I document every new virtual machine that comes up as part of a particular application, and I'm covered. And you can really, really streamline this process where the IT infrastructure group manages these virtual machines. They have a bunch of configuration spec documents for each of these virtual machines, and they can perform a simplified IQ on these virtual machines, saying, "Hey, I use this template. This is the memory configuration. This is the CPU configuration, and these are the tools that are built, on top of this virtual machine. These antivirus software and whatnot, net backup agent, etc." And they can spin these out a lot faster, and you can really laser focus on the virtual machine deployment process and qualify it from that perspective. And it really speeds up your time as well. So the virtual machines themselves now sit on an underlying virtual infrastructure. So what do these virtual machines really need from the virtual infrastructure? Perhaps it's things like high availability. I don't want my virtual machine to die. I don't want my application to stop because there's a hardware failure. Perhaps there's a high availability requirements, and you test against those high availability requirements. Perhaps you want to have the flexibility of moving these virtual machines from host to host. Using something like dynamic resource management tools or vMotion, hardware, storage vMotion, etc. So these are some requirements that the virtual machines have of the underlying virtual infrastructure, and we can build those up as requirements in a functional requirement spec of my virtual infrastructure and qualify against those as well. The advantage of that is it really lays down your infrastructure, and you really know exactly what you're committing to, what your service level agreement is with the applications group, for example. And you've provided a slew of services that the applications can essentially tap into. They can tap into high availability. They can tap into vMotion or isolation, compatibility, security. They can also tap into things like disaster recovery if they really want this application to have a quick RTO or a quick recovery time objective, they can essentially tap into tools like VMware's SRM, etc., and have their virtual machines and their data replicated to another data center. So you qualify those underlying infrastructure services that the infrastructure layer provides, and in this case, this virtual infrastructure provides, and then essentially you're done, you're set. Then it's all just provisioning. You need a new virtual machine, or you need an application requires disaster recovery capabilities. Well, here you go, fill out this form, we'll provide it for you. This is a qualified service, and it's done. And of course, to take the argument a little further, I know we're focusing on virtual infrastructure qualification, but you take that argument a little further. You can also, the underlying virtual infrastructure needs something from what it's residing on. It resides on hosts. It resides on a storage area network, for example. It needs Active Directory or directory services, etc. So you qualify your underlying network infrastructure as well, which can support this virtual infrastructure, and it can support physical infrastructure as well, physical machines as well. So your SAN can be qualified. Specific features of your storage area network can be qualified. Example, snap mirror technologies, where you're snap mirroring, these virtual machine data stores as well as other data from data center A to data center B. You can qualify that, prove that it works, etc. So it kind of follows a very layered approach. You start with the application at the top, the virtual machines fall below that, the virtual infrastructure falls below that, and then finally you have the other infrastructure components that support the virtual infrastructure, like your physical infrastructure, directory services, networking services, etc. So that, in a nutshell, is a quick synopsis, and I try to be cognizant of the time, and I think I ended just about on time. So feel free to post questions, and I'll take questions for about another 5-10 minutes or so. But the idea is to continue this discussion on the LinkedIn discussion board that Becky mentioned as well. So feel free to either send me a private chat or send Becky a chat, and I'll try and respond to some questions.
Thank you, Sabu. Really appreciate you sharing that very solid information. As Sabu mentioned, we will open the floor to questions now. And while you're typing those in, I'll remind you that the session has been recorded and will be available on our website, which of course is usdatamanagement.com. I'd encourage you to take a look at that site, and you can see there a list. You can review the upcoming webinar events as well as our recorded sessions from previously presented topics. Let's see, it does look like we have some questions coming in. Our first one is from John. He's asking, how do you handle physical to virtual moves from a validation perspective?
That's a great question, and let me think about that for a second. I guess the easiest way to talk about that is to talk about an example. So we recently worked on a virtual infrastructure qualification project. And the way we approached the problem was we qualified the underlying infrastructure, and then we brought in systems that were residing on bare metal servers, and we were bringing them in one by one. So bear with me while I lay this out. So the first thing we did was we qualified the virtual infrastructure, proved that all of these different capabilities of the virtual infrastructure actually worked. We built a functional requirement spec for this virtual infrastructure. We proved high availability works and vMotion works, et cetera, Site Recovery Manager works, et cetera. Then we had a priority list of systems that we needed to move over, and the first system there were 4 or 5 systems in the first phase. One of them was OpenText LiveLink, which is a content management system. The other was ARIS-G, which is an adverse event reporting system, and another one was SAS, the statistical system, and I forget the 4th or 5th one. There were a couple of others. The interesting point that for LiveLink was OpenText was not supporting VMware, especially for this particular version of LiveLink that the customer had. but the customer was still keen on trying to move this over to a physical infrastructure. So there are a couple of things that we did. So and the OpenText Live Link out of these 4 or 5 systems was the most complex. So we essentially had a P2V, like a mini project, a P2V migration qualification effort. So what we did was we said, hey, we're going to move this from physical to virtual. And as part of the virtual infrastructure qualification, we proved that the P2V tool works, and we tried that with a couple of different things, couple of different operating system types, so we know that the P2V tool works. When I say P2V, I mean physical to virtual, by the way. So we did a P2V migration for Live Link, and we had a risk assessment document that basically identified, we clearly stated that, hey, there were many risks associated with moving OpenText Live Link from physical to virtual. The vendor doesn't support it, so we need to mitigate those risks, etc. So we came up with a bunch of things. One was we said we will fossilize the bare metal servers, meaning we will keep them as is. That means it still has the Live Link application installed on the variety of servers. And we'll also keep a bare metal database server, and the database was Oracle. We'll keep a bare metal database server ready to go. And once we move the Live Link environment from physical to virtual, we'll data guard, which is basically a data replication technology. We'll data guard the database from the virtual to the physical bare metal box, and it'll just be sitting there replicating actual production data. So in case we truly have a catastrophic failure, we can always bring up the physical machines. We can bring the physical machines up. And it was also a risk mitigation strategy. We wanted to keep the bare metal for, I think, a year, I think was what we decided. If we felt comfortable that the OpenText Live Link environment ran for a year without any serious issues, then we could retire the physical machines. So that was a strategy. And the other thing we did was, as part of the P2V, we in the risk assessment we said a lot of the URS items or the functional requirement items for OpenText Live Link we're going to kind of test again. So we're going to do an end-to-end regression testing, maybe of 50-60% of the critical features of the system or the critical requirements of the system. So we weren't taking any risks in that regard. So once we moved over, we actually ran through like a PQ, OQ-PQ combo document, which was almost 50% of the initial OQ-PQ that was done. Then the second system that we brought over, we said, hey, this worked great. It passed, the OQ-PQ passed. The issues that we encountered were non-technology related or was trivial or was easily resolved, or the deviations we encountered were easily resolved. We're going to bring RSG over, which is the next most complex system in the suite. And instead of doing 40-50% of the URS, we're going to take a little more risk and do a more muted testing, say 20-30% of the OQ-PQ that we did in the past. And I'm making up these numbers of 20%, 50%, but we just said, I think it was the highs and the medium risk URSs were tested in the in Live Link, and it was just the medium, only the highs were tested in RSG, etc. So we brought the RSG over. We tested it, proved it worked. SAS was a very simple system from an architecture perspective. So we took a significantly lower testing strategy for that P2V move and kind of tapered down in the same way. So that's the way we approach that problem, and I'm hoping that kind of answers your questions. If you have more specific questions, again, feel free to contact me, and we can discuss this at great length.
Thank you, Sabu. Our next question is from Larry. He's asking, do you need to test a virtual server on each host in your VMware farm?
No, that's not the strategy we deployed. I think you mean how do we prove that the virtual machine works on every host that you have in your farm? The way we've approached it in the past is we've, as part of, it's kind of implicitly tested when we do, testing, of dynamic resource management or vMotion, etc. We kind of cycle through a variety of our hosts in the infrastructure. And we document the fact that it works on these various ESX hosts or ESXi host platforms, and we take the risk that it'll work on the others. I think it's overkill if you try to test it on each host in your farm. It depends on how complex your farm is. You may choose to just do it if your QA is insistent that it's tested on each host. Then if your farm is small enough, it may not be worth the effort of making the argument or the fight. But if you can make a cogent argument as to why you can just test it on a couple or 2 or 3 hosts, I think the argument can be made.
Very well. Okay, we have another question. It's from Suresh. He's asking, Annex 11 emphasizes testing disaster recovery. How do you use Qualify VMware's SRM? How does this help prove that a system has tested DR plan?
I think you're asking, if we qualify SRM, how do you know that it tests every individual system's disaster recovery plan? And that's a good question. It doesn't prove that that every system can be recovered. You must test out individual systems recovery plans, and you should probably do that on a frequent basis anyway, maybe once a year or once in 2 years, depending on your risk tolerance. Qualifying the underlying infrastructure enables you to bypass some steps. Qualifying SRM's capabilities, for example, just enables you to not have to test all of those individual things that you would have tested for an individual application. You can have a very simple application test protocol for testing disaster recovery, where you say, hey, failover ABC system and prove that it works on the other side by running like a system suitability test, log in, run a report, make sure it works, etc., and then fail back. So it will not qualifying SRM will not prevent you from testing your individual system's disaster recovery plan, but it will help you mute the amount of documentation or paperwork that you may have to do for the individual application's disaster recovery testing, if that helps.
Tremendous. Thank you, Sabu. So thank you to those of you who are posting compliments and thank yous here on our chat board. We appreciate seeing those. What we'd really like is to see them out on our LinkedIn group page, though. So we do invite you to join the discussion forum on LinkedIn because we need your insight, your feedback, and your suggestions for future topics. If you appreciated today's presentation, please let us know by clicking on the like button on the USDM LinkedIn group. You can see the link there in the chat room. And even better, if you have a moment, please do post a comment for us. It'll take just a few seconds and would be very useful, as in 2012, this is an important indicator that our management team is looking at and using as a basis for deciding to continue to fund the complimentary webinar series. And again, thank you, Sabu, for providing such solid information, and thank you all for taking the time to join us today. On behalf of the U.S. Data Management Team, we appreciate this opportunity to team with you towards excellence in compliance. Have a great day.